NASA Jet Propulsion Laboratory has developed the Exploration Rover for navigating extreme slope terrain, or Earnest. Earnest is a new class of rover with a minimal set of actuators and a 2 degrees of freedom active gimbal suspension. It has advanced mobility capabilities designed for exploration of steep and rugged terrain on the Moon and Mars. Shown here mounted on a pedestal, Earnest has 4 steerable wheels that allows it to drive in straight lines in any direction, including sideways, and arcs about any center of rotation. A 6-axis force-torque sensor measures interaction with the ground at each wheel. A transverse rocker joint in passive suspension mode keeps all 4 wheels in contact with the ground automatically as Earnest drives over undulating terrain. The passive rocker can be switched into an actively controlled joint using a pair of solenoid-driven bolts to rigidly couple the rocker arm to an actuator. The active rocker joint combined with a pivot joint rotating about a vertical axis forms Earnest's active gimbal suspension. Earnest can be driven using an external power source through an umbilical connected to its switch panel or using onboard batteries. Earnest is a fully functional rover with onboard avionics, computing, motor controllers, sensors, and a wireless communication interface to enable autonomous navigation and mobility. In its passive suspension mode, Earnest is shown driving with all the capabilities of a conventional fully steered rover at JPL's outdoor mini-yard rover test facility. In its active suspension mode, Earnest can additionally drive with several alternative gaits, including squirming, and lifting any of its wheels off the ground. Earnest wire mesh wheels provide compliance, as shown here, when driving rapidly over a bed of rocks, while in its passive suspension mode. When driving over ripples in loose sandy material, passive suspension vehicles can become trapped and not have the ability to escape. By activating its active gimbal suspension, Earnest shows that it can escape from this hazardous situation. On a 35 degrees ramp composed of loose sandy material in the mini-yard, Earnest shows that it is not able to climb the slope when in its passive suspension mode. Switching to its active suspension mode, Earnest successfully ascends the ramp. Earnest then climbs down the platform after reaching the top of the slope. Earnest's active gimbal suspension can also be used to climb large step obstacles. In the passive suspension mode, Earnest front wheels easily clamber over the wheel height step obstacle, but its rear wheels are not able to surmount the step. Switching to its active suspension mode, Earnest can lift its wheels in sequence through a coordinated motion of its rocker and pivot joints and drive wheels to step up onto the platform. Earnest's robust mobility system is shown here, driving sideways down the wheel height platform. A classic trap for four-wheel passive suspension vehicles is a half-wheel height object that the front wheels easily climb over, but the rear wheels cannot surmount. The vehicle is subsequently not able to drive either forwards or backwards because the wheels cannot drive over the obstacle. Earnest shows that it is able to overcome this type of trap using its active suspension. Earnest's unprecedented mobility capabilities in a minimally actuated four-wheel vehicle configuration could lead to a new class of low-cost planetary rovers for exploration of previously inaccessible locations on Mars and the Moon.